All right, the last thing that we're going to talk about, last type of example, is going to be permutations of duplicate objects. The number of distinct permutations of n objects where n1 of the objects are identical, n2 of the objects are identical, all the way through nr of the objects are identical is found by the formula n factorial over n1 factorial divided by n2 factorial divided by n3, n4, however many different things we have that are repeated. So we're going to start with just kind of a simple example to show this, and then go through one that has a few more digits and is a little bit more complicated. So in how many different ways can the letters of the word Bob be arranged? All right, so in our rule, our top number, right, is going to be the number that is of original letters that we have. So in our particular case here, we're going to have n factorial, which is going to be the number of things that are in letters in the word Bob. And then we are only going to have n1 factorial because we only have one letter that has repetitions, right? So we are going to have 3 factorial because that's the number of letters that we have in the word Bob, right? And then we are going to have, if we look at this, just do this way, we have 2 letter B's, so that is our n1. Right, so since we have 2 of the same letter, we're going to do 3 factorial divided by 2 factorial. Right, this is going to give us 3 times 2 times 1 divided by 2 factorial is just 2 times 1. Right, everything cancels and we're just left with the 3. Right, so a little tiny example with a little tiny word just to show us how the formula is going to look. If we wanted to verify, if we thought about the 3 letters that spell Bob, we could check this one just because there aren't a lot of different possible combinations. We have B, O, B, same forwards and backwards, B, B, O, or we could put the O first, followed by the 2 B's. So just not anything that you have to worry about. You don't have to worry about going through and finding all the possibilities. It's just nice to mention that it is something in this case where we only have a few possibilities that is possible. All right, so for example B, we're going to do the same thing. And how many different ways can the letters of the word? But now we are going to look at Tallahassee. Right? So when we set up our formula, we are going to start with our n factorial. And then if we look at this, we have the letter A repeated. So n1 factorial. We have the letter L repeated, n2 factorial. We have the letter S repeated, that's going to be n3 factorial, and we have the letter E repeated. So that's going to be the n4 factorial. So we have a factorial for each different number that is being repeated. All right, now, if we count the letters in Tallahassee, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have 11. So we're going to start off with 11 factorial. Again, I'm going to use n1. That's going to be A. We have 3 A's. So we're going to have 3 factorial. We have 2 letter L's. So 2 factorial. We have 2 letter S's. So that's going to be another 2 factorial, and we have 2 letter E's. So that's going to be another 2 factorial. Right. So again, I'm going to kind of write this all out. So in my numerator, 11 times 10 times 9 times 8, 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, you're more than welcome to use your calculator and work this out different ways. 3 factorial, 3 times 2 times 1. 2 factorial, 2 times 1. Another 2 factorial, 2 times 1. Another 2 factorial is another 2 times 1. All right, so if we go through and we start crossing these off, this 3, 2, and 1, right, those can cross off because we have a 3, 2, 1 here, 3, 2, 1 here. If we were to look at this, 2 times 2 times 2 times 2, and all of those ones, that actually gives us 8 if we multiply that all out together. So I'm going to cancel out this whole thing with my number 8. And so all of that's gone. So then if I multiply what I have left, 11 times 10 times 9 times 7 times 6 times 5. Again, you don't have to do this a long way. Feel free to use your calculator. Figure out what 11 factorial is, and then your 3's and 2 factorials. And this is going to give us, again, if we just shorten it to 11 times 10 times 9, 7 times 6 times 5 times 4, this gives us 831,600 possible arrangements. Right, so when you're dealing with duplicate letter permutations, just remember that your top number should be the total, and then you're dividing it by anything that is being repeated.